So our final speaker before lunch will be Donny Persaud. Extraterrestrial broadband touches down, constructing nature and global internet connectivity with low Earth satellite internet infrastructure.
Whoops. Back here. All right, so hopefully you can still see me. I had to bring my laptop up here because I wasn't able to print my script in time. So this talk synergizes really well with the previous speakers, given the historical angles and the emphasis on relationality in terms of how we conceptualize nature and the environment. So I'm Donny Persaud, a PhD candidate in the Department of Science and Technology Studies at Cornell University. I'm a sociologist of technology, and I look at how infrastructures like satellite constellations reshape understandings of nature, the environment, and technology, generate social conflicts, and how these influence the development of newer technologies. And right at the start here, I want to pose a question to you that was spoiled. Where does the human environment end? Where does nature end and technology begin? And how do we establish these boundaries? And ideally, this will be more clear by the end of this talk. So what we're going to focus on today is the environmental and cultural impacts of satellite constellations on the night sky, atmosphere, and astronomical research that are generating significant debate over the boundaries between humans, nature, and technology through calls for different variations of regulatory regimes and protections for outer space. So to start here, I want to draw your attention to this excerpt that's from the legal narrative that SpaceX submitted to the Federal Communications Commission, the FCC, the U.S.'s regulatory agency for telecoms, from 2018. And this was for a partial modification to Starlink that would lower about 1,600 satellites by half their altitude to 550 kilometers here. Is there a laser pointer? Sweet. All right, so here SpaceX says that the atmosphere acts like a vacuum cleaner. At lower altitudes, sweeping low Earth orbit clean of debris. And when I first read this, I thought it was incredibly interesting, as SpaceX, they're doing a few things here. They're noting that atmospheric decomposition of satellites is a desired outcome, so disposability is a design factor. They suggest that the atmosphere can tolerate ongoing decomposition of satellites and other space debris, and that the Earth's atmosphere itself is a critical component of Starlink's infrastructure for it to operate successfully, acting as a mechanism that can be used by future satellite constellation operators as well. So these issues concerning satellite internet connectivity and their material impacts on outer space emphasize some important principles for sociologists of technologies. First, infrastructure development. It's where we can gain insight into how socioeconomic, cultural, and environmental differences can be produced, reproduced, and resisted. Second, nature has certain qualities conditioning how it can be exploited, extracted, or commodified. And this is reflected in efforts to divide the world into controllable or technological domains and uncontrollable or natural domains. And third, the boundaries between humans and nature are historically and culturally specific. And there's an extended history of these principles emerging and coming together where certain terms or knowledge end up shaping discourses that structure and redefine relationships between humans and nature. For example, the terms frontier and wasteland and terra nullius, they were used by colonial settlers to describe select environments and socioeconomic behaviors to justify the seizure of land from indigenous peoples, or urban blight, for example, being used to expropriate land from historically black neighborhoods within the United States. So with these principles in mind, the key issue that we're going to focus on here today is how are satellite constellations reshaping what is considered nature? And the core of this talk is that SatCons reinforce the inseparability of humans and nature as SpaceX attempts to make the atmosphere a part of Starlink's infrastructure. So I'm going to make two overarching points here. First is analyzing scientific expertise opens up contests over nature concerning what it is, who knows it best, how it should be managed, and who is best suited to do this. Second, nature is and can be infrastructure. And the term infrastructure, it's really tricky. It usually implies like material artifacts and structures, and nature conventionally signifies its absence in popular conceptions. But I'm going to posit to you here that infrastructure, it's not something that's set ahead of time. It's actually a process that sees different components, both natural and technological, come together. And this is done through the technical, discursive, political, and economic actions of different stakeholders. Excuse me. And in this process, certain stakeholders aim to reshape human-environment relationships for specific purposes. And right now, in many ways, it feels like we're in a position where we are repeating a lot of past actions seen throughout the history of technology, where certain technologies were framed in a specific manner to justify or facilitate certain socioeconomic behaviors and political goals, and where newer technologies were deployed before they were more understood, usually with important and lasting consequences. But it need not be this way. So to explore these shifting boundaries between humans, nature, and technology, I want to dive into some of the argumentation that's appeared in two appeals that have been brought against the FCC in the United States over Starlink. And the first here is an appeal made by the satellite operator Viasat to stop SpaceX's modification in 2021 that changed the primary operational altitude of about 2,800 satellites. This was dismissed by the Court of Appeals on August 26, 2022. And the second one here is an appeal that was made by the International Dark Sky Association against the partial approval granted to SpaceX to construct, deploy, and operate up to 7,500 second-generation or Gen 2 Starlink satellites. And this appeal is ongoing. I think the oral argument's been scheduled for November, but I need to double-check that. So in assessing these, I'm not going to be speculating on the outcome of the ongoing appeal, and I'm not going to be saying which party is right or wrong. I'm not a lawyer. I'm looking at how the parties involved are constructing boundaries between humans, nature, and technology based on the views that they have and how they're interpreting existing regulations. And my hope here is that by assessing how these boundaries are presently constructed, it can expand dialogues on what a more comprehensive, inclusive, and environmentally just regulatory framework could look like for outer space in the future. So to start, the National Environmental Policy Act, or NEPA, was enacted in 1970 in the United States, establishing the national environmental policy for the nation and the process to implement it. U.S. Congress recognized the profound impact of man's activity on the interrelations of all components of the natural environment. So NEPA doesn't actually require the decision maker to select an environmentally preferable alternative or prohibit adverse environmental effects. It's a procedural statute that's meant to facilitate better decision making for federal agencies. The Act also formed the Council on Environmental Quality that issues binding regulations for U.S. federal agencies to meet these NEPA obligations. So there are 3 levels of review for federal agencies to assess proposals, and the one that we're interested in is the categorical exclusion that we were introduced to during the keynote speech earlier today. So categorical exclusions signify a category of actions that an agency has determined do not have a significant effect on the human environment, and this is based on the agency's past experience with those kinds of activities. So the FCC's interpretation of NEPA differs from other federal agencies like the Federal Aviation Administration, for example. Since 1986, they've categorically excluded all actions from review, save for a small number of exceptions listed in the regulations. And the FCC's rules largely focus on environmental effects that are at the Earth's surface, so the operation of satellites has not generally triggered those exceptions. The implementing regulations given to U.S. agencies also provide several definitions for important terms, but these introduce notable ambiguities, and the most pertinent here are human environment and effects. These are the May 2020 definitions, as these were what were in place at the time of the Starlink modification and the Starlink Gen 2 application, but since this point, changes have been made and agencies are working on updating their respective NEPA regulations. So what's noteworthy about these is the words natural, physical, and even relationship here, they don't have clearly defined limits, and there's no mention explicitly of outer space or the orbital environment, and this has led to a lot of federal agencies interpreting their NEPA responsibilities differently. So Critical to this is a rule within the FCC's regulations that allows an interested person to file a petition requesting an environmental assessment for a order that they're looking to authorize. And if you appeal it and the submitted evidence that you provide shows that there may be a significant environmental impact, then the person who submitted that application will be required to do an environmental assessment. And this is referred to as the May standard. So in 2021, Viasat challenged the 2021 Starlink modification over concerns concerning the unknown and cumulative effects of satellite launches and reentries on the atmosphere, increased light pollution, and increased risks for satellite collisions in low Earth orbit, suggesting that the evidence that they presented exceeded that May standard. And the appeal was dismissed in court, and it provides valuable insight into how environmental expertise is used to argue for a specific form or idealization of nature. And one major point of contention was the impact of aluminum on the atmosphere during satellite decomposition. And within current literature, it suggests that aluminum deposition in the upper atmosphere will increase the Earth's albedo, cooling the planet. It may absorb longer wavelength radiation, thereby warming the planet instead. It will increase the formation of high-altitude clouds whose effect on climatic systems remain unknown. And it may contribute to ozone loss in the stratosphere. So the FCC recognized that Viasat and SpaceX disagree about the amount of alumina that SpaceX's satellites could produce in the atmosphere. Viasat asserted that any dispute over the magnitude of environmental effects from SpaceX-produced alumina is a reason to require an environmental assessment, noting that the issue wasn't over the amount of alumina produced, not that it will cause harm, right? Suggesting that the May standard had been met. Conversely, SpaceX argued that the evidence from Viasat didn't show plausible risk of significant environmental effects specific to alumina from their 2,800 satellites, noting that Viasat's assumptions, they were based on a much larger number of satellites that they were assuming all alumina in the upper atmosphere would react, and SpaceX said this is highly unlikely to happen. SpaceX also pointed out that the remaining evidence in the record used by Viasat provided estimates of the cumulative effects of satellites and rockets launched by several companies, not just them. And the FCC's position on this was that they didn't see how the evidence in the record indicated a significant impact specific to those 2,800 satellites, asserting that the mere presence of some environmental effects doesn't necessarily rise to the level of demonstrating a significant effect on the environment. And these positions here can tell us a few things. So the debate here isn't about over whether alumina will impact the atmosphere, but about how it will impact it. The may have a significant impact wording that exists in the FCC's rules leads to this problem of definition, where stakeholders argue for different and sometimes opposing meanings of impact based on how may or significant are emphasized. More broadly, some scientists and activists would argue that any alumina in the atmosphere would be a significant environmental impact given its presently unknown effects, while others would state that something must be scientifically demonstrated as a detrimental environmental impact. The same can be said of whether individual impacts are as important as the cumulative impacts of alumina deposition. For instance, SpaceX's final brief in this case quoted Professor Andy Lawrence's brief that supported Viasat, where he did state that the environmental impact of any particular proposal may be modest, despite his emphasis on the cumulative effects of these Starlink satellites and the incapability of the FCC's rules to capture these, which was, it was on page 12 and 13, and then immediately the next line gestures to that. So these arguments echo earlier historical moments like the emergence of germ theory and the discovery of nuclear radiation, as well as current discussions over marine plastic pollutants, where emerging forms of pollution were thought to cause negative health impacts, but the kinds of impacts and what was considered appropriate evidence of those impacts was under debate, setting implicit questions about what counts as harm and for whom and for what. And this ruling reaffirms the naturalized and institutionalized forms of environmental management used by many governments today, better known through theories such as assimilative capacity or the threshold model of pollution, where pollution can be measured and managed within allowable limits. Such models serve as the basis for key environmental laws in the United States, like the Clean Air and Clean Water Acts, and these tend to separate individualized impacts and effects from the broader structural harms that are enacted and being done. as these forms of environmental management note that some environmental impacts are allowed and even accepted as normal or reasonable. A significant impact marks when pollution or harm is being done, and that these impacts are observable, measurable, and traceable by lab rather than non-scientific methods. And the use of such argumentation in this case here, as well as recent changes to the FCC's satellite disposal rules that limit low Earth orbit satellites to a period of 5 years before they have to be removed from orbit, suggests that we could be heading towards this form of environmental management for the atmosphere as well. So the second case here is the ongoing appeal between the International Dark Sky Association and the FCC and SpaceX over the partial approval of the 7500 Gen 2 Starlink satellites. The IDA and their co-appellants argue that the FCC should conduct an environmental assessment under NEPA because Gen 2 Starlink, as proposed, may or will have a significant impact on the human environment. For many of the same reasons that Viasat listed in their appeal, but here they're placed in the context of the quantity of satellites approved by this single order, as it's almost equivalent to the total amount of satellites launched up to this point in human history. The FCC acknowledged that the IDA's request for NEPA environmental review, it raised novel questions of the Act's applicability to outer space. Nevertheless, the FCC assumed, without making a formal decision, that NEPA review would apply to the SpaceX application. Notably, this appeal sees the IDA push for confirmation of NEPA's applicability to outer space by asserting that it is part of the Earth's human environment, arguing that the Earth's orbital sphere is an integral component of the environment, given its multifaceted cultural and scientific relationships with humans, the FCC's efforts to regulate and control the Earth's orbital environment through their approval process, and the NEPA Act's emphasis on the worldwide and long-range character of environmental problems. Conversely, in this case, SpaceX argues that the court should take the opportunity to confirm that Congress limited NEPA's regulatory scope to the human environment and biosphere, taking care to place humans outside of the environment and biosphere in their argumentation, suggesting that without a threshold ruling here, NEPA could continue to be weaponized by competing satellite operators like Viasat, which is how they were understanding the respective challenges to their applications. So ultimately here we see competing understandings of outer space that rely on a specific kind of relationship humans have with it, one that points to the social relationships humans hold with the night sky and the hands-on management of the Earth's orbital environment. Conversely, the other emphasizes its inability to support life and exclusion from terrestrial-based biological processes as the rationale to exclude the orbital environment. And this legal and discursive maneuvering done by these respective actors in this case, their attempts to incorporate nature into Starlink on SpaceX's part and resist that incorporation on the IDA's part, since at stake is an integral part of the current life cycle of satellite constellations as they're designed, since operators rely on atmospheric decomposition for their disposal. And what's notable here is that SpaceX is arguing that the orbital environment doesn't count as part of the human environment, and the NEPA standards need not apply to ensure that they can continue to use the atmosphere for satellite disposal, yet they're doing so while noting the distinct environmental threats SATCOMs present to humanity while in orbit. Remember, in the 2018 application, they asserted that the atmosphere acts like a vacuum cleaner, sweeping debris away and ensuring a sustainable orbital environment for all, distinguishing their understanding of orbital sustainability and outer space sustainability from the form of outer space sustainability and the protections that are sought by the International Dark Sky Association. This conflict reveals the flexibility of how we argue for and against nature based upon the presence of technologies like satellite constellations. SpaceX demonstrates their ability to navigate the ambiguity of existing U.S. environmental standards, and the emerging challenges to that maneuvering are premised upon the multifaceted relationships humans have with outer space that are seen as under threat. So ultimately, where does this leave us? The aim here has been to highlight how technologies like satellite constellations can reshape our understandings of nature, done through the competing knowledges and formation of specific boundaries between humans and nature to advocate for certain human-environment relationships over others, as has been the case in earlier iterations of terrestrial infrastructure development. Here, it's arguable that we're witnessing the transformation of the Earth's atmosphere into an environmental sink to maintain a novel telecommunication infrastructure, to be managed within specific limits premised upon the forces of atmospheric drag and its physical separation from the requirements needed for life. But again, it need not be this way. The presence of SATCOMs presents a moment we should seize to recognize the concurrent and often conflicting understandings humans hold with nature. How are we implicated in these relationships? Do we wish to continue to rely on governance systems premised upon the assumption that we can manage nature that is external to us, an assumption that has built theories and models central to the innumerable climatic and ecological crises we imminently face? Or are there other ways to approach our relationship with nature, to affirm that the well-being of our environment is a fundamental human right, to adapt to changes in ways that avoid reasonably preventable harms, to think reciprocally about our relationships with the environment instead of framing it as something that needs to be managed? And these concerns over outer space may seem far removed, out of sight and out of mind to many within the general public at large, yet just like terrestrial infrastructures, satellite constellations reaffirm and deepen our ties to nature through their differentiated and unknown and emerging impacts on the night sky, atmosphere, and outer space, reminding us that try as we may to separate ourselves, we are nature as we make it. Thank you.